Hello, I'm going to talk about camera-only localization, edge detection, and lane keeping system for urban roads and motorways. I'm Dr. Yong Luo. I did my PhD in computer science at University of Durham in the UK. And many car companies now have developed put their own automated lane keeping systems called ALKS, and for big and relatively straight roads. Companies like Tesla, Ford, and BMW has their own products and is in use at the moment. But there are some problems. I will give you some example roads to explain the problem. For example, this road is quite big and straight road. So for this kind of road, it is relatively easy to deal with. But for this road, this is a sharp left-handed bend. It is become harder to predict driving directions or predict where the edges are. Another kind of road is a right-handed bend. It's a sharp bend. Uh, this is a different kind of road. There's no clearly marked edges. There's no curves. The edges just bushes and trees. This can be difficult to decide where the edge is. Our solution for this problem is to use camera only, to use machine learning model. So our model works on both big roads and narrow roads. Now in this presentation, we only focus on narrow urban roads and sharp bends, like I mentioned before. Our machine learning model only use cameras, i.e. computer vision, slow GPS data needed. I will explain this a little bit more later. The workflow for our product is that first we use front forward-looking cameras built inside the cars or buses or any vehicles to capture the road videos and pictures, and then we label the landmark or edges of the pictures or the videos, then build a training dataset or testing dataset. The third step is we use machine learning and techniques and to train our model and evaluate our model. And if necessary, we will adjust training parameters. And this will lead to compare all the parameters, which parameters is important, or which parameter is will affect the result of predictions. And then use our trained ML model, machine learning model to detect vehicles location and where are road edges and predict the driving directions. Our results. At the moment, we only work on left-hand road edges. We labeled left-hand edges for 4 kinds of roads. I just mentioned before, and big straight road is one, and the left-handed bend, right-handed bend, and the other is uncommon road edges. At the moment, we have a training dataset that only has about 600 training data, which is quite small compared to uh, industrialized datasets. This is our results. This is a big straight for big and a straight road. You can see the predictions. You can see the small green and red dots. That's our prediction for this road. You can see it's a pretty accurate prediction. This is for the left-handed bend road. Um, it's not as accurate as the straight road, but it's pretty good prediction. It's just centimeters, percent. Yeah, in a centimeters distance, I think. Yeah, it's quite close. And this is a right-handed bend. For this one, is very very accurate. You can say, and this is a different kind of road edge. It's pretty accurate. So the results we showed so far is very promising. And of course, we need to do more in the future. Now, future work. First of all, we need to build large training data sets for different kinds of roads. At the moment, we only have 600, about 600 data, training data, which is very small, and we need to label the edge positions or driving directions and so on. But this task is not that difficult, but we need to employ people. We need resources to employ people to do this task, labeling of videos and pictures. Another related kind of future work is about warehouses. In the warehouses, there's kind of lots of heavy machines to move around and the goods and to move to the different positions. And they have some kind of driving kind of road inside warehouses. If we use our kind of technology, we can also predict the driving directions or where the other edges are. Um, Another important issue we need to emphasize that because inside the warehouse there's no GPS available normally. So, but fortunately for us, we use camera only. We just use cameras, so we don't need GPS data. Finally, another important future work is that we need to compare training results and adjust training parameters. And this task can be challenging and needs a lot of expertise on computer vision and machine learning. And that's all for today. If you have any questions, please email me. My email address is here. Thank you.